Hello everyone, welcome back. Now let us start problem number 22 on page number 509 of Griffiths Electrodynamics, chapter number 12. So the problem says, draw a space-time diagram representing a game of conversation or a catch between two people at rest 10 feet apart, how it is possible for them to communicate. So let us draw first of all the time axis and the, or you can say the time Minkowski space axis or space-time diagram. So first of all, if two people at rest. So if two people are at rest, then it means that their x-axis is not changing, only the time axis is changing. So their world lines are like this, first of all, and they are 10 feet apart. 10 feet apart. He's saying given that their separation is space-like, if separation is space-like, slope is negative, as we know that, and this is first person, this is second person. He's saying that they are playing a game of conversation. So if this person says hello from here, it reaches here in this time. The time is also increasing, x is also increasing as the conversation has covered 10 feet. Now he receives that conversation, and suppose he says hello. He receives that hello, and then he transmits his signal, that is hello from here again. Then then he takes time to receive it, then transmit its signal from here. He's saying how are you. Then he receives that, and then again it transmits like this. So this is the game of conversation which will be going on like this, and this is called the game of catch or game of conversation. So this is the space-time diagram. Now talking about the B part. What is B part? There is an old limerick that runs as follows: there once a girl named Bright who could travel much faster than light. She departed one day the Einsteinian way and returned on the previous night. All right. What do you think? He's saying that a girl who can she can travel with a speed faster than speed of light. So even she could. Then he's saying that what do you think? Even she could travel faster than light. Could she return before she set out? Yes. How? In her axis, as you can see that this is the formula in her axis. So if V is very greater than C, but the denominator is still greater, so this will be less. This factor will be less as compared to the if velocity is less than C and if velocity is greater than C. So this component will be greater as compared to this value. And even when the gamma when V is greater than C, gamma also decrease. This term will also become negative. So in total, delta T dash will decrease. So in her reference frame, she will notice that she has returned on her place on some time which is less than the previous time. So yes, you can say that if a girl or a boy is traveling faster than speed of light, then in her axis she can reduce the time, or she can return to the previous night. You can say that. But if we are talking about our axis, then could she arrive at some intermediate destination before she set out? Yes, she can arrive if we are talking about in our axis. Then he's saying draw the space-time diagram representing the trip. So suppose this is time and this is space, and this is suppose world line when she starts from rest from her home. Suppose this is H. So she starts from here. She went somewhere. Suppose she went to the market. Then again she is returning. But now in the space-time diagram, as we can see that as she is returning, time is also increasing, and the distance from her house is same. So distance is also increasing. So in our axis, we can see that the she went from here to here. We can see that time is increasing. So she didn't came on the previous night. Uh, coming on the previous night means she has decreased the time axis. She returned somewhat here, but in our axis time is increasing. From which perspective, or from which reference frame we are seeing her. So that is why this is the space. This line will not come in the space time. So this is the space, and this is the you can say the world line in her axis. So you can say that uh, home to market and market to home. So time increasing, axis increasing. So we can say that in our axis it is not possible, but in her axis, in her reference frame, it is possible. So this was the explanation of this example or this problem. So if you have any doubts, let me know in the comment section below. I'll be helping you. Thank you. Bye bye.